The next we are going to see next case of the deletion, that is deleting the last node from the list. Okay, deleting the last node from the list. In the previous video you saw deleting the first node from the list. So what we have done by using this chart, okay, right, what we will delete, we will remove that particular node and we will make the second node as a start. So that is deleting the first node. And now we are going to see deleting the last node. So here what we have to do, we have to use one condition. So that is ptr tends to next, it is not equal to null. So why we are using this condition is we have to know which is the last node, right? That is, we need to find the last node. So after finding the last node only, what we can able to do, we can able to delete the last node. So by using this condition, what we are doing, we are checking for the last node, and once we find the last node, by using the free function, we will remove that particular node. So we will see the code. So here we are using two pointer structure variable, that is ptr and pre-ptr. The next what we are doing, we are assigned ptr is equal to start. So what we are doing, we are making this start node as a ptr node. Then next we have to check the condition ptr tends to next is not equal to null. So we are checking ptr tends to next. So it is not equal to null. So this condition is true. If this condition is true means this loop will be executed. So what we are doing, we are making we are assigning pre-ptr is equal to ptr. So this is the node ptr node. We are making this as a pre-ptr. Then this ptr is equal to ptr tends to next. So what will happen, this node will become as a ptr node. Then again we have to check this condition ptr tends to next is not equal to null. So now this is the ptr node and next is, it is not null. So again this condition is true. So again what will happen, it will become as a pre-ptr and this is a ptr. Okay, now again we have to check the condition ptr tends to next is not equal to null. So it is not equal to null. So again we have to execute this. So what will happen, ptr node become as a ptr pre-ptr and next node as a ptr, and in a ptr we are checking here. So it is not a null. So the condition is true. So what will happen, this node become as a pre-ptr and this is a ptr. Then we are checking the condition ptr tends to next. So it is true, condition is true. So we have to execute the while loop. So this is the pre-ptr now and this is a ptr. Then again we are checking ptr tends to next is not equal to null. Yes, it is not equal to null. So what will happen, it will become as a pre-ptr and now this is a ptr. Then again we are checking the condition ptr tends to next is not equal to null, but it is not, it is equal to null. So what happens, this condition becomes false. So it will come out of the loop, okay, and it will assign pre-ptr tends to next. So in the next pre-ptr tends means this particular part, it will become as a null. Okay, so this become as a null, and by using the free function we are removing the node from the list and it will be removed from the memory also. Okay, so here we are using this condition is important. So by using this condition only, what we are doing, we are finding the last node and we are removing the node from the list. And this is the algorithm and the code. So first we have to check the underflow condition. Then you can see it is the same only. So ptr is equal to start, we have assigned. Then we are using the while loop ptr tends to next is not equal to null. We are checking this condition. If this condition is true means what we have to do, pre-ptr is equal to ptr and ptr is equal to ptr tends to next. Till this condition getting false, what we have to do, we have to execute this statement. So once it got false, we have to come out of the loop and we are using this pre-ptr tends to next is equal to null, same. Then free the ptr. So the same procedure only. So this is for deleting the node at the end. So here we have to find the last node and we have to remove the node from the list.